Good morning, students. In the last grade, we had seen about the equilibrium. The body is said to be in equilibrium if it maintains its state of rest or state of motion under influence of several forces. And I explain you the two types of equilibrium. First is static equilibrium and second one is dynamic equilibrium. What is static equilibrium? When a body remains in a state of rest under influence of several forces, then it is known as static equilibrium. Now today we are going to see about dynamic equilibrium. Let's start. Second is dynamic equilibrium. Okay. Dynamic equilibrium means what? When body remains in state of motion. Body remains in a state of motion under influence of several forces. When body remains in a state of motion, यानी body उसकी motion में ही रहती है under influence of several forces. Lot of forces are acting on the body. आगे से नीचे से बाहर से आजू बाजू से सब जगह से उसको फोर्स लग रहा है, फिर भी बॉडी उसकी वेलोसिटी मेंटेन रख रही है, उसकी मोशन कांस्टेंट रख रही है. देन वी कैन से ओके, देन बॉडी इज सेड टू बी इन डायनामिक इक्विलिब्रियम. ओके, let's say an example. First, raindrop. Raindrop comes to the earth with constant velocity. With a constant velocity. What happened over here actually? The raindrop, which is falling to the earth, having its own weight, exerted a force in downward direction, and the air exert a friction force in upward direction. And both the forces, one is in downward direction due to the weight, and other is due to the friction of air in upward direction, are equal in magnitude and opposite in direction. Because of that, both get cancelled. And these forces, when get cancelled, then the velocity of the raindrop is constant. And that is nothing but the definition of the dynamic equilibrium. When body remains in a state of motion, whatever its motion is, under influences of several forces, one is in downward, other is in upward direction, but these forces get cancelled with each other and body maintains its velocity. So that is known as dynamic equilibrium. Second example is aeroplane. Aeroplane moves at a constant height. Moves at a constant height from Earth. Okay? Aeroplane moves at a constant height from the earth because its weight balances, which is in downward direction with upward lift. Aeroplane takes an upward lift, right? Aeroplane takes an upward lift and the weight is in downward direction. Weight. of aeroplane is in downward direction. And this upward lift of the aeroplane and the weight of the aeroplane in a downward direction balances the aeroplane, okay, at a constant height. At a constant height. Means several forces are influencing to the aeroplane, but still aeroplane is at a constant height. Third, a stone when tied to a rope and whirled, ओके, स्टोन लगा दिया, एक रोप को हमने स्टोन लगा दिया, इसको एक स्टिक से पैक कर दिया और हमने ये स्टिक को रोटेट किया. ओके, अ स्टोन टाइड टू द रोप एंड whirled in circular path, then stone gains circular motion. Okay, stone gains a circular motion. This motion, the stone moves with a constant velocity. Okay, stone moves with constant velocity due to force exerted towards center. Exerted toward center because of tension in the string. Tension in string, right? String में tension होने के कारण this stone rotate in a circular path because here the centripetal force is produced. Centripetal force is produced and tension of the string keeps it balanced. Actually the force is in outward direction of the stone, but the tension in the string keeps it inside. Means it exerts the inside force. And both the forces magnitude same get cancelled with each other. So the stone rotates in a circular path at an equal distances. Similarly, we can take an example of the planets which are revolving around the sun. Next example, the electron revolve around the nucleus. Next example, satellites revolve around the planet. These all examples gives us a dynamic equilibrium. Next is condition for equilibrium. What are the conditions for equilibrium? First condition is that the resultant of all forces acting on the body should be zero. Now here, if a body is there, say a balloon, and the force F1, F2 acting in this way, F3, F4 from upward and downward. But if force F1 is equal to F2 and F3 is equal to F4, then the forces will get cancelled due to their equal magnitude and opposite direction. So we can say that the resultant of all the forces acting on the body should be zero. Okay, this is the first condition. Second, algebraic sum of all moment of forces exerting on body should be zero. Actually, this is for a pivoted body. This is pivoted body. This is pivoted body. Pivoted means, say this is a fulcrum, or here one of the forces, in this side. Okay, forces are here. Now in this case, what we find? One is in if this force is in this case, or I say beam balance here, so this is also F. This turns the body in anti-clockwise manner and this turns in a clockwise manner. So this gives us anti-clockwise turn, and this side force F2 gives clockwise turn. Okay, clockwise turn. So here what we find, this anti-clockwise and anti-clockwise moment of force of the body should be equal. Means algebraic sum of all the moment of forces exerted on the body should be 0. Okay? Anti-clockwise always taken as positive and clockwise taken as negative. So sum of these two forces which produces a moment of force in anti-clockwise manner and other produces in clockwise manner. Okay? These are the conditions for equilibrium. Question is asked, state the condition for body to be equilibrium. Now next is principle of moments. Next one, principle of moments. Just I explained in this diagram, similarly when a several forces acted on the pivoted body, they tend to rotate the body. They tend to rotate the body about the axis. So the resultant of all the moment of all the forces about pivoted body, we find algebraic sum at that point. Okay? So according to this principle of moment, we find anti-clockwise moment of a body is exactly equal to clockwise movement. Okay, clockwise movement of the body. So this is known as a principle of moment. And best example or a device which works on this principle is a beam balance. Beam balance works on principle of moment. So keep in mind. You know that in a beam balance, okay, two pans are there like this. Now we are keeping a standard weight on one of the pan, and then the things which we want to measure in the other pan. So here a standard weight which have a known quantity. इसको हमें known है, इसकी quantity हमें known है. And here we are measuring unknown quantity with known quantity, right? So here this pan turns in downward direction and gives a moment of force in anti-clockwise manner. Anti-clockwise manner, which is taken always positive. And this pan in which we have kept unknown quantity for a measurement turns or provides a clockwise movement. Provide clockwise movement, and which is taken as negative. Both are equal, then and only then we can say it balances. So the principle of movements tells us that anti-clockwise movement is equal to the clockwise movement. In ICSE, last year this question is asked. State the principle of moment as well as give an example, one example of a machine which works on this principle of moment. So beam balance is an example. Give one example on which on a principle of moment it works. So beam balance works on this principle of moment. Okay, I hope you all understood this. Similarly, for the examples, we need a formula. So if I take a rod and if I do a fulcrum at its middle, at one of the end a force F1 is exerted and other end force F2 is exerted. If this fulcrum, if a force at a corner or anywhere on the either side, say at a distance d1 from the fulcrum, and the second force exerted say at distance d2 from the fulcrum, then by principle of moment we can say that F1 d1 is equal to F2 d2. In your book it is given as W1 L1 is W2 L2, means this F1 we can say as a weight W1, F2 we can say weight W2, and this distance given as a L1 and this distance as a L2, we will get W1 L1 is W2, sorry, W2 L2. Understood? So this is again a principle of movement, because it depends on the principle of movement, and this formula we can use when we are going to solve these numericals. Okay, so those numericals we will see in a one period. In the next period we will see these all numericals related. Second thing, after every chapter we are going to keep your Zoom meeting in which questions will be asked to you, whether you have any difficulty in that chapter. Every teacher is going to take this Zoom meeting after each chapter. If any teacher is not taking a Zoom meeting after a chapter, you inform me, right? So you download Zoom app, that I am going to put a message. Similarly, yesterday I got a phone call for a notebook list. So you ask your subject teacher, okay, for a notebook. For a physics, I want 200 pages notebook. Thank you.